All right, so this video is meant to walk you through the in-class examples for work since I'm not there today. So let's just go through them. 4 kilogram jars, give an initial push, moves up a 10-degree incline, initial 128 joules of kinetic energy. How far up the incline will it slide? So let's just digest what we know, right? We know the mass is 4 kilograms. We know the angle is 10 degrees. Initial kinetic energy is 128. It slides up it, and we're wanting to know like how far it slides up, and so the assumption is that K final is 0. And mu is 0.3, and we're trying to find the distance. So right now, the only thing that we know that relates distance to energy is this idea of work kinetic energy theorem. So work kinetic energy theorem says that work is equal to a change in energy. In this case, it's a change in kinetic energy. So I know that work is equal to FD cosine of theta, and that is equal to my K final minus my K initial. Now I'm trying to find this distance. In terms of this force, I need to figure out what is the force that's causing this change in energy. And if I think about my forces, draw a force diagram here. Here I've got weight. And of course I would break that up into a Wx and a Wy, and this is mg cosine of 10, and this is mg sine of 10, right? That's just forces on an incline. And then I have normal force, and I have friction. So if I think about the forces that are causing the change in kinetic energy, there's two. There's this force and there's this force. There's friction and then there is weight. And those are both pointing like downwards. So if I think about my distance, I'm gonna go color crazy here. The distance this thing moves is like this direction. So when I think about the angle between this distance and the force that's causing the change in energy, the distance is going this way. The forces that are causing the change in energy are going down the slope. So when I think about the angle between those two, that angle is 180 degrees, okay? So keep in mind, this angle right here in this situation is 180 degrees because the angle between the distance and the force that's causing the change in energy is 180 degrees. So in terms of what this force that's causing the change is friction and Wx, okay? It's those two forces, friction and Wx. And so when I would write it, I would say friction plus Wx, those are my forces that are causing that change, times the distance times cosine of 180 is equal to K final minus K initial. So a couple things that I can simplify this. Cosine of 180 is just -1, and my K final is 0. And I could also simplify like what this F is and then what this Wx term is. So let's go ahead and do that. So friction, the equation for friction is mu times normal force. Wx is this mg sine of 10 times this distance times -1 is equal to negative kinetic energy. Okay, I've got a negative here on both sides so I can cancel those out. And I got to do one more kind of simplification here, this normal force. Normal force for an inclined plane, the normal force is equal to Wy. So I could say mu times Wy, which is mg cosine of 10, plus mg sine of 10, and that's all times my distance, is equal to my initial kinetic energy. So at this point, you should be able to plug your values in and solve for the distance. So I'd have like 0.3 times my mass of 4 times 9.8 times cosine of 10 plus 4 times 9.8 times sine of 10 times distance is equal to 128. And you should be able to solve for the distance. So calculate that out. Get out your handy dandy calculator. Calculate that out. I am not going to calculate that out for you. You're going to do that. You're going to put an answer down there. You can confer with a teammate nearby. What'd you get? What'd you get? What'd you get? I will go over that answer in class tomorrow or the next time I see you. Okay, so calculate that out. Okay, second question. A wagon is pulled a horizontal distance of 15 meters. Handle the wagon makes an angle of 20 degrees with the horizontal. Girl exerts a force of 35 on the handle. Friction provides a force of 24. Okay, so let's just look at what this is like. Radio flyer wagon. In terms of forces, I've got weight, I've got normal force, I've got this pull at this angle. So I'd say this is FPX, this is FPY, and then I've got friction. And I know some values, like I know my force of my pull is 35 newtons. I know that the force of friction is 24 newtons. I don't know what the mass of the wagon is, so I don't know the weight. But if I'm thinking about find the net work done, this wagon is moving horizontally, like it's moving in that direction. So I am only really concerned about forces that are in that direction. So the only forces that are in that direction or along that axis are FPX and friction. So when I go to think about how I'm trying to find my work is equal to force times distance times cosine of theta. The two forces that are doing work on this are FPX and friction, and they're actually working against each other. So FPX minus friction times distance times the cosine of the theta. And FPX would just be 35 cosine of 20 minus friction, just notice 24, times the distance of 15 times cosine of 0. Why is it cosine of 0? Theta is 0 degrees because the net force is parallel to the distance moved. Right? My net force of FPX minus friction, like it is overall in that direction of distance. So the angle between right and right is 0. So go ahead and calculate this out and get an answer. Again, I'm not going to tell you what that answer is right here in this video. You should be able to calculate it, confer with the teammates. You should be able to come back to class, and I can see you've got an answer there. Okay? So those are the in-class examples for work.